NEC Article 700.5b addresses systems consisting of a generator intended to supply both emergency and legally required standby loads. The article states if the generator is intended to supply both emergency and legally required standby loads, the generator shall be sized and connected to provide all of the emergency and legally required standby loads as a unit. In other words, a generator that supplies both emergency and standby loads must be sized and connected to provide for all of the loads as a unit. The generator cannot be split into two separate systems, one for emergency loads and one for standby loads. In a situation where a generator is currently supplying emergency loads, such as lighting and elevators, and is intended to be expanded to also supply a UPS for computer backup, which is a legally required standby load, the NEC requires that the generator be sized and connected to provide for both the emergency and standby loads as a unit. Therefore, the UPS cannot be connected to the existing emergency panel that is supplied by the generator. A separate automatic transfer switch, or ATS, must be installed off the generator to supply the UPS and other non-critical standby loads. There are additional considerations. NEC Article 700.11 requires that emergency systems be installed and maintained in a manner that ensures their reliability during an emergency. Connecting the UPS to the emergency panel could compromise the reliability of the emergency system if the UPS fails or malfunctions. NEC Article 700.5 requires that emergency system circuits be kept separate from all other electrical systems. Connecting the UPS to the emergency panel could violate this requirement. To reiterate, if a generator is used for both emergency and legally required standby loads, the generator must be sized and connected to handle all loads as a single unit. The key takeaway is to avoid connecting a UPS to an existing emergency panel supplied by a generator. Instead, install a separate HES for the UPS and other non-critical standby loads. This configuration ensures compliance with the NEC and maintains the reliability of the emergency system. It is important to consult with a qualified electrical engineer or contractor to ensure that all electrical work is performed in accordance with NEC and local codes. They can assess the specific requirements of the installation and provide guidance on the appropriate sizing, connection, and protection of the generator, ATS, UPS, and other electrical equipment. Ensuring that the generator is properly sized is crucial. The generator must have sufficient capacity to handle the combined load of the emergency circuits and the legally required standby circuits. This calculation should take into account the starting inrush current of motors and other inductive loads, as well as the continuous load requirements of all connected equipment. The selection and installation of the automatic transfer switch, or ATS, is also critical. The ATS must be properly rated for the voltage, amperage, and fault current of the system. It must also be designed to automatically transfer the load from the normal power source to the generator in the event of a power outage, and vice versa when the normal power is restored. The ATS should be tested regularly to ensure that it is functioning properly. Regarding the UPS, it is important to select a UPS that is appropriately sized for the load it will be supporting. The UPS should have sufficient capacity to provide backup power for the computer equipment for a reasonable period of time, typically at least 15 to 30 minutes. The UPS should also be equipped with surge protection to protect the computer equipment from voltage spikes and other power disturbances. Furthermore, proper grounding is essential for all electrical equipment, including the generator, ATS, UPS, and computer equipment. Grounding helps to prevent electrical shock hazards and to minimize the risk of damage from lightning strikes and other electrical faults. All grounding connections should be made in accordance with the NEC and local codes. It is also important to consider the ventilation and cooling requirements of the generator, ATS, and UPS. These equipment generate heat and require adequate ventilation to prevent overheating. The equipment should be installed in a well-ventilated area, and cooling fans or other cooling devices may be necessary to maintain the equipment within its operating temperature range. In addition, it is important to regularly inspect and maintain the generator, ATS, and UPS. This includes checking the oil level, coolant level, and battery condition of the generator, as well as inspecting the ATS and UPS for any signs of damage or wear. Regular maintenance can help to prevent equipment failures and ensure that the system is ready to operate when needed. Also, consider the placement of the generator. It should be located in a secure area that is protected from the elements and from unauthorized access. The generator should also be located away from flammable materials and should be equipped with a fire extinguisher. Ensure proper labeling of all electrical panels and equipment. All electrical panels and equipment should be clearly labeled to identify their function and the circuits they serve. This can help to prevent confusion and to ensure that electrical work is performed safely and correctly. Then, verify compliance with all applicable codes and standards. All electrical work should be performed in accordance with the NEC local codes and any other applicable standards. It is important to obtain all necessary permits and inspections to ensure that the work is done correctly and safely. In summary, when installing a UPS in conjunction with an emergency generator system, it is crucial to adhere to the requirements of NEC Article 700.5b. This means that the generator must be sized and connected to provide for both the emergency and legally required standby loads as a unit, and that a separate ATS must be installed off the generator to supply the UPS and other non-critical standby loads. It is equally important to consider the additional requirements of NEC Articles 700.5 and 700.11, which address the separation and reliability of emergency systems. Failure to comply with these requirements could compromise the safety and reliability of the emergency system and could also result in code violations and penalties. Always consult with a qualified electrical professional for specific guidance and assistance. He or she can help you to design and install a safe and reliable emergency power system that meets your specific needs and requirements. Furthermore, remember that the NEC is a living document that is updated every 3 years. It is important to stay up to date on the latest changes to the code and to ensure that your electrical work complies with the current edition. The NEC is not a substitute for proper training and experience. Electrical work can be dangerous, and it should only be performed by qualified professionals who have the knowledge, skills, and equipment necessary to do the job safely and correctly. In addition to the NEC, there may be other applicable codes and standards that you need to consider, such as the National Fire Protection Association, or NFPA 110, which covers emergency and standby power systems. NFPA 110 provides requirements for the performance, testing, and maintenance of emergency power systems, and it can be a valuable resource for ensuring that your system is properly designed and operated. You should also be aware of any local codes and regulations that may apply to your electrical work. Local codes may be more stringent than the NEC in some areas, and it is important to comply with all applicable requirements. When selecting a generator, consider the fuel type. Generators can be powered by gasoline, diesel, natural gas, or propane. Each fuel type has its own advantages and disadvantages, and the best choice will depend on your specific needs and requirements. Gasoline generators are typically less expensive than diesel generators, but they are also less fuel efficient and require more maintenance. Diesel generators are more fuel efficient and durable, but they are also more expensive and produce more emissions. Natural gas and propane generators are cleaner burning than gasoline and diesel generators, but they require a connection to a natural gas or propane supply line. Also, consider the noise level of the generator. Generators can be quite noisy, and it is important to select a generator that is as quiet as possible, especially if it will be located near residential areas. Many generators are equipped with noise reduction features, such as mufflers and sound dampening enclosures. Next, think about the transfer time of the ATS. The transfer time is the amount of time it takes for the ATS to switch the load from the normal power source to the generator. A shorter transfer time is generally better, as it minimizes the interruption of power to critical equipment. However, a shorter transfer time may also be more expensive. Finally, remember to document all electrical work. Keep detailed records of all electrical work performed, including the date, location, and description of the work, as well as the names of the electricians who performed the work. This documentation can be helpful for future maintenance and troubleshooting, and it may also be required for insurance purposes. To summarize the key points, firstly, NEC Article 700.5b requires that a generator supplying both emergency and legally required standby loads must be sized and connected to provide for all loads as a unit. Secondly, a UPS cannot be connected to an existing emergency panel supplied by a generator. Thirdly, a separate ATS must be installed for the UPS and other non-critical standby loads. Fourthly, NEC Article 700.5 and 700.11 address the separation and reliability of emergency systems. Fifthly, consult with a qualified electrical professional for specific guidance and assistance. Sixthly, stay up to date on the latest changes to the NEC and other applicable codes and standards. Seventhly, ensure that all electrical work is performed safely and correctly by qualified professionals. Eighthly, consider the fuel type, noise level, and transfer time of the generator and HES. Ninthly, document all electrical work performed. By following these guidelines, you can help to ensure that your emergency power system is safe, reliable, and compliant with all applicable codes and standards. This is crucial for protecting people, property, and the environment in the event of a power outage. Now, let's discuss some common misconceptions about emergency power systems. One common misconception is that any generator can be used for emergency power. However, not all generators are created equal. Emergency generators must meet certain performance standards to ensure that they can provide reliable power in the event of a power outage. For example, emergency generators must be able to start quickly and to maintain a stable voltage and frequency under varying load conditions. Another common misconception is that a UPS can replace a generator. While a UPS can provide backup power for a short period of time, it is not a substitute for a generator. A generator can provide backup power for an extended period of time, which is essential for critical facilities such as hospitals, data centers, and emergency response centers. It is also important to understand the difference between emergency power and standby power. Emergency power is required by code for life safety systems such as lighting, fire alarms, and elevators. Standby power is not required by code, but it is often used to power non-critical loads such as computers, office equipment, and manufacturing equipment. Emergency power systems must be designed and installed to meet stricter requirements than standby power systems. For example, emergency power systems must be able to operate independently of the normal power source, and they must be tested regularly to ensure that they are functioning properly. Finally, it is important to remember that emergency power systems are complex and require regular maintenance. Neglecting maintenance can lead to equipment failures and can compromise the safety and reliability of the system. Regular maintenance should include checking the oil level, coolant level, and battery condition of the generator, as well as inspecting the ATS and UPS for any signs of damage or wear. The system should also be tested regularly under load to ensure that it is functioning properly. In conclusion, understanding the requirements of NEC Article 700.5b and other applicable codes and standards is essential for designing and installing a safe and reliable emergency power system. By following the guidelines outlined in this discussion, you can help to protect people, property, and the environment in the event of a power outage. Always consult with a qualified electrical professional for specific guidance and assistance. He or she can help you to design and install a system that meets your specific needs and requirements, and he or she can also help you to maintain the system properly to ensure that it is always ready to operate when needed.